So there are two ways to do this question. The first one is by graphing these two functions, and we're looking for their intersections. So this is our straight line, and the y-intercept here is -5. X-intercept would be here, and then slope 1. So that line is going to look something like that. The graph of absolute value function, and I think this is where it pays to kind of have done something like that before. You start with the graph of just y equal to 2x minus 3, which will be y-intercept of -3, and then slope is 2x, so it's going to open up like that, steeper than this, because that has a slope of 1, and it's going to look something like that. So you can immediately recognize that there will be no intersection, so there are no solutions. If you wanted to do it algebraically, yeah, I guess we can just directly deal with this. The way you would do this is, first condition would be if 2x minus 3 is greater than or equal to 0, that would be equivalent to x is greater than or equal to 1.5. Then you remove the absolute value, because when it's positive, that would just be 2x minus 3. And then you solve for x, and you'll find x is -2. But this solution doesn't satisfy that condition, so that means that is not a solution. In fact, you can also notice if you plug it back in, you would get -7 here, absolute value, and -7, but this is 7. So this is not a solution. The other case would be 2x minus 3 is negative, which is equivalent to x is less than 1.5. In this case, the absolute value of 2x minus 3 would be minus of 2x minus 3, and then we equate this to x minus 5. Find the corresponding value of x, which would be 3x equal to 8, or x is 8 over 3. But notice here, x needs to be less than 1.5, which this number doesn't satisfy. In fact, it's 2 2/3. So this is also not a solution, which means there is no solution. So you can take either approach. I did them both ways, actually, in the exam. So it depends how quickly you can do, but either one will give you the answer, which is choice A.